So if that plutonium on that Mars rover, which is to be launched in this window, November 25 to December 15th, ends up being released, if there's an accident. In fact, the NASA environmental impact statement for that mission declares that the chances of an accident releasing plutonium on this mission is 1 in 220. I mean, if you knew you would take a drive to San Diego and the odds were 1 in 220, you're not going to make it.
Wow. Well, they are.
You might not go to San Diego. But in any case, the odds are 1 in 220 the plutonium would be released. The cost of the mission, and we're all worried about money these days, the cost of this mission itself is, this Mars plutonium rover mission, is $2.5 billion. If there's a release of the plutonium, according to this is the official NASA environmental impact statement, the cleanup cost, the decontamination cost, would be as high as $1.5 billion for each square mile irradiated
in an urban setting. And Carl, we're going to get into that in just a moment because we're going to go to news in about a minute. But I want to really understand plutonium because we hear the word plutonium, we know it's radioactive, but I don't know that everybody gets that plutonium is the scariest stuff man has ever created. That one pollen-sized, as a flower would emit for a small bee to grab and carry. One pollen-sized piece of plutonium can give you cancer and kill you. And we're talking 10.5 pounds of this stuff.
Yeah, a millionth of a gram of plutonium is a fatal dose. It's an alpha emitter, and the issue is breathing in that microscopic particle that gets lodged in the lung, irradiates that a portion of the lung, and lung cancer is the inevitable outcome. It's been described as the most toxic radioactive substance of them all, and there's stiff competition in that regard. It's man-made. In fact, it was discovered or developed in your state, in California. In fact, I once interviewed the lead scientist in the discovery of plutonium, Dr. Glenn Seaborg, and what occurs is that uranium-238, a little technical, but people should understand it, which doesn't split when hit by a neutron. What does happen when it's hit by a neutron is that some of the 238 changes and becomes plutonium-239. And why they were very interested in it when Seaborg was doing this work, 41, 42, is that they didn't think they had enough high-grade uranium to make atomic bombs. The Hiroshima bomb was highly enriched uranium. They then had plutonium, and plutonium will do the same thing as uranium-235 will do. In other words, it's fissile. It'll split. So the Nagasaki bomb was a bomb with plutonium as its fuel, and essentially every atomic bomb since uses man-made plutonium, and the hydrogen bomb uses a plutonium trigger. So plutonium is very important, and furthermore, because there's a concern about whether they'll have enough high-grade uranium ore to use in nuclear power plants, the scheme, it's been the plan for years of the nuclear establishment, is to go to plutonium. They call these breeder reactors as the fuel in nuclear power plants. This most toxic of all radioactive substances.
Carl, I'm just going to ask you to pause for a second. We're talking to Carl Grossman. He's professor of journalism at the State University of New York College at Old Westbury, and recently wrote the article, NASA's Solar Probe. And what he's saying is that NASA has said for years that it could not, impossible to use solar power in outer space, not enough sun out there. Now they're using it. And then coming up in the next number of months is going to be using radiation, plutonium. And the problem is that if there's a problem on the launch pad, as we've seen with how many rockets now, whether they're ICBMs that are being tested out of Vandenberg locally or anywhere else, when these things misfire, that kind of plutonium, and NASA says 1 in 200 chance it could end up going all over Earth.